Okay, so we are going to learn how to solve systems of equations by graphing. So what does that mean? Well, that means for us right now, we've got two lines. We're going to graph them and we're going to find out where they intersect. Is there a point at which they intersect, for instance? So let's graph these two lines. I'm going to start with this line. I'm going to graph it in orange. So it's in slope-intercept form, so I'm going to graph my intercept, -1, 2, 3, 4, 5. And my slope is rise up 1 over 2, rise up 1 over 2. And I am going to draw that line with my ruler. Alright, so that's one line. So now let's graph the next line. We've got the line y equals -4x plus 4. So we're going to plot our intercept. It's at 4, 1, 2, 3, 4. It's also in slope-intercept form. And then we're going to do our slope. Down 4, 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1. Okay, so already we see that these two lines are going to intersect. And they intersect at the point 2, -1, 2, 3, 4. So they intersect at the point 2, -4. That is our point of intersection. And that is also our solution. That point is on both of the lines, and that is why they intersect at that point. So when solving a system of two equations, we may get a point of intersection. Now let's do the next example. All right, so we're going to start out, let's start out with our orange. I like orange first. And let's plot our intercept, 1, 2, 3, 4. And then our slope, down 1, left 1, down 1, left 1. Well, I can do that because down 1, left 1 has a slope of 1, right? And that is good. So let's draw that line here in orange. Okay. Well, the other equation of our line, well, it's not quite standard because we've got this negative coefficient here. But we really want that to be in slope-intercept form. So let's convert that to slope-intercept form over here. Let's add 3x to both sides. And we're left with 3y is equal to 3x minus 6. And we're going to divide by 3. And we're left with y is equal to 3 divided by 3, that's 1 minus 2. So now we can graph that line. So we've got intercept at -2, slope of 1, up 1, over 1, up 1, over 1. Okay, and now we graph that. Well, these two appear to be parallel. Our blue line has a slope of 1, and our orange line has a slope of 1. And that means that those two lines are indeed parallel. Oops, parallel lines. So that means that they have the same slope, and it also means that they will never intersect. So what are our solutions? Do we have a point of intersection? No. There are no solutions. If we have two parallel lines, they are going to have the same slope, and we will never have a point of intersection. So we have no solutions. Okay, next we're going to graph this line. So remember, when we graph, it's nice to have it in slope-intercept form. So I'm going to bring my x over, and I'm going to divide by 3 to every term. And I'm left with -1/3 x plus 2. So that's the first equation I've got. So let's graph that. So we've got an intercept at 2, down 1 over 3, down 1 over 3. now let's graph the next one in blue. So again, I'm going to take that line and I'm going to put it into y equals mx plus b. So let's add 2x to both sides. Now let's divide by -6 to each term, and we're left with -2 over 6x. So 12 minus 6, well, that's plus 2, right? Negative divided by negative. And we can reduce this further to -1 over 3x plus 2. Wow, so look at that. We've got two of the same equations. So we're going to graph it again, just for the sake of graphing, -1 over 3. So every point on this line is going to be on top of every point on the other line. So we've got a line on top of a line. Well, that means that we have infinitely many solutions. And why is that? Well, because each line is composed of infinitely many points. So all of these points make up a line, right? Well, if you have a line laying on top of a line, well, that means that there's an intersection of infinitely many points. Each of the infinitely many points on one line sits on top of the other line. Can you see my hands? That means one on top of the other, and that means we have infinitely many solutions. And that is it.